Good afternoon. Welcome to Math 106. It's good to see all of you. We're a little bit understaffed at the moment. There are 23 people registered for class, and there are many fewer than that in this room right now, but it's 1 o'clock and we start at 1 o'clock. I won't be surprised to see some stragglers on the first day. The 4th floor north is quite a bit further than most people realize it is. So you guys are here on time. We'll go ahead and get started, but probably there'll be some people joining us in the next few minutes. So there are 3 different packets or 3 different handouts that are on your tables. So make sure you get one of each. One of them at the top is it's just a one piece of paper. It says key prerequisite skills. These are some problems that I'd encourage you to look at over the weekend, and certainly by a week from now, having that page done. I'm not going to collect it, so it's not officially assigned, but it's stuff that you're expected to know. And if there are gaps in your knowledge, finding out that there are those gaps earlier rather than later is in all of our best interests, okay? So at the end of each section here, it says, if you have trouble with these problems, come see me, all right? So it's broken into sections. Let me know ASAP if any of these things are giving you difficulty. I do my best to try to put answers as often as I can, and there's an answer key at the bottom. Oops, answer key at the bottom of that page, right there. Okay. All right. The next thing that you guys have in front of you is a few pieces of paper. It's the syllabus at the top. It says Math 106. We will talk about that, but we're not going to talk about that first. But does everybody have one of those? Yeah. Okay. Syllabus. All right. Okay, and then the last thing that you guys have is the real thick one. And this packet represents basically our notebook for the first half of the semester. We're just going to be filling this thing in. I'm not going to give you another one of these on Monday. This is really taking us almost to the middle of the term. And when we get there, I'll give you a second packet, and that'll be it for the whole semester. So we'll go ahead and start up here with number 1. And I'm wondering if we can get Katrina. Can you read number 1 to us, please? Okay, give it a shot. First, introduce yourself. Maybe you two guys could make a table together. Introduce yourself. See if you can get X for those 2 equations. Okay, so I think most folks are just about done, if not done. I've written what I saw a lot of people write on their own papers. I've got it up here. One nice thing about the stuff that happens up here is that at the end of every week, I'm going to turn this into a PDF and post it on our Moodle page. So anything that's up here, you don't need to feel obligated to write down like word for word, letter for letter, right? You'll have access to this. I'll post it every Friday afternoon, probably not today because it's the first day, but generally Friday afternoons I'll post it. So you'll have a copy of that if you want it. The first equation, I think everybody nailed perfect. The second equation, there's one spot that is so easy to make a mistake, and it's right here. What's the easy mistake to make right at that spot? Is to make it a plus instead of a minus, right? So easy to forget that that negative sign is required by law to come in and distribute through everything, all right? So it's very tempting to make that a +8 instead of -8. I think everything else is okay. In the key prerequisites thing, that one page that we looked at, oops, that one page that we looked at has a bunch of linear equations for you to solve. So certainly there's more practice there, and we'll give you a lot more practice with it today. Can we go on to number 2? And is it Davis? Number 2, please. Okay, so let's just do this as a group. There's not too many of us. Anything that comes to mind in terms of solving linear equations, just shout it out. Great. Other things. AX plus BY equals C. Thank you. Other stuff about solving linear equations. Raise your hand if that looks familiar. Hoping it looks familiar. Anybody remember what that thing stands for? What the M is? The slope. We're going to spend a lot of time this semester talking about slope. Absolutely. Great. What was the first thing that you guys did for this first equation up here at the top? You subtracted 3 from both sides, right? All right, there's a couple of things going on, and even if it's very natural for you to look at that and say, okay, subtract 3 from both sides, I still just want to pause here and say, okay, there's some stuff going on that you might be taking for granted. First of all, why is it a subtract 3? Yeah, we want to get rid of it. Currently it's a positive 3. We need to do the opposite of whatever we see there, right? So that's kind of one of these fundamental things about solving equations, is that you need to do the opposite of what you see. What did we do at this stage? 5x equals 20. What did we do next? Divided by 5. Why did we divide by 5? Because it's the opposite of multiplying by 5. So I'm just going to add that to our list down here. Oftentimes solving equations, not just linear ones like these, but equations involves doing the opposite of what you see. And I'll just write that same example from up above. That plus 3 to all of you guys turned into, oh, subtract 3. That's what we need to do. Okay. And then one more thing I want to say about this equation. We didn't just subtract 3 from the left-hand side, because that would be cheating. What did we do? Subtract from both sides, right? You have to do the same thing to both sides. Whatever you do to one side, you must do to the other. And to be honest, if I had to name just like 2 things that I think are the most important 2 things in all of algebra, that's one of them, is whatever you do to one side of an equation, you must do to the other. Again, we take it for granted, but it's important to just pause and understand that's just one of these fundamental things we have to always be aware of. Whatever you do to one side of the equation, you must do to the other. Okay, so we'll go to Drew. Can you read number 3, please? Okay, so that equation looks quite a bit worse to me than the first 2. What do you like? What do you see in there that you don't necessarily like? Fractions. Okay, and said with the proper amount of disdain over here. Fractions. Okay, so how do we handle fractions? Well, I mean, the 2/3 sitting here in the front seems to me to be kind of begging to be distributed. Like that seems natural, right? Take that 2/3 and multiply it by both terms in the parentheses. You're not obligated to do that, but I'm going to start there. So let's distribute that 2/3. So the first thing we get is 2/3 b plus, close, 2. Okay, because we're doing 2/3 times 3. I'll just put this over here on the side. I don't know how much detail folks need on this, but if I'm doing 2/3 times 3, is it clear to you guys? You can cancel those 3's, you just get a 2. Is that okay? It's equal to 2. If you want, you can put it over 1 here if you really need to see it look like 2 fractions. So that 2 right there is the same as the 2 that I've just put there. And then I'm going to copy the right-hand side. Okay, here's one technique you can use to get rid of all these messy fractions. So first of all, fractions indicate there's some division happening. So if I want to undo that, what am I going to be doing? Multiplying, right? The opposite of all this division stuff is some multiplication of some kind. And what I want to do is multiply both sides by the same thing. I have to do that. I want to multiply by something that's going to clear all of those fractions. For example, if I multiply over here, this thing right here, if I multiply it by 3, then that 3 is going to cancel with the 3, yes? That's a good thing. And the 3 that's out here is going to come in and make the 2 a 6. That's fine, no problem there. But I'm happy that the 3 cancels. But if I multiply there by 3, I got to multiply here by 3. And that 3 doesn't really go so well with that 4. It doesn't cancel it. So 3 is not the best number. 3 is good for 1, but not for all. What number would you like to multiply this by to get rid of that denominator? It's 4. But that's not really going to help so much with this. What would you like to multiply that by? 12. Can you find the smallest number that's going to get rid of all of them in one fell swoop? Is that 1? So I've heard a 6. Yes. So we definitely need a 3. So I'm just going to start building. 3 is going to get rid of this. What's going to get rid of the other guy over there, the first fraction? It's 4. Well, I got to do the same thing on both sides. So I'm just going to start collecting here. So 3 and 4 will get rid of the 2 fractions. That's currently a 12, which is kind of miraculous, but it happens to get rid of the last one too. So I think we're done. 12 takes care of everything. So I'm going to put a 12 here. Multiply the left side by 12, and at the same time, what else do I have to do? Multiply the right side by 12. So we'll squeeze that in there. Okay, and then we're going to distribute. You see a number outside of parentheses almost every time you're going to distribute. So let's distribute. And I'm actually not even going to do the fraction work. I'm just going to copy every term down. So 12 times 2/3 of b, I'm just going to write it, plus 12 times 2. And you do the same kind of thing on the right side. 12 times everybody is all we're writing down right now. Everybody okay with what we wrote? I think for a lot of what we're going to do here, it's going to be far better for you to try to figure out what, like to try to write down what we're trying to do as opposed to copying and then trying to figure out what I've got up there. I think it's a lot more meaningful to you to try to figure out what are we doing and then check up here to see if you did it right. And if you didn't, then ask a question. That'd be great. But copying this, like without knowing where it came from, it's not going to help you understand anything. You just make copying. Everybody understand where that came from? Okay, so now we're ready to start canceling. This is the fun part. So that 12 and that 3 reduces and gives me what up here? Yeah, 3 goes into 12 4 times. 3 is gone completely. If you want, you could put a 1 down there, but I'm not going to put it. 12 times 2, okay, that's just 24. We'll deal with that. Let's handle the next 2 fractions. So go ahead and cross off the 12 and 4. Replace the 12 with whatever is left over. So 4 goes into 12 3 times. And what happens on the last term? Yeah, 12 and 12 cancel completely. And now I'm going to write down what's left. What I find is that a lot of algebra is being really careful about reading what you've got because sometimes it's quite messy. And if you don't read all the symbols properly, you end up with the wrong answer. You haven't made any algebra mistakes. You've just made some reading mistakes. So what do I have left up here in this mess? I have a 4, I have a 2, and I have a b. All multiplied together gives me ab, right? Multiply them together. Plus 12 times 2, 24. That part was never the problem. And then look at your paper and really carefully figure out what's there in this next term. There's a 3, there's a 5, there's a b, 15b. And then plus 17. And after all that work, what have we gotten rid of? Fractions. That's a really powerful technique. If you're solving an equation with fractions, multiply both sides by the magical number that gets rid of all the fractions. Sometimes it's hard to find that magical number, but that's the technique. This one looks like the ones up above. Go ahead and finish it and check your answer with your neighbors. Together. So I think just about everybody's got b equals 1. Wonderful. We're going to go to the next page, but before we do that, we got to slow down and just do some kind of technical detail stuff. So can you guys open to the other handout that has syllabus at the top? Okay. How are we doing here? Good? All right, come back to that in just a minute. Okay, here's the syllabus. Absolutely no chance we're going to read this to each other. It would be boring as sin. Let's not do that. part of your homework for the weekend is going to be to read through it. There's a lot of information there. I'm going to try to limit myself to 2 minutes. If I go over 2 minutes, I'm going to stop talking, and that'll be that with the syllabus, okay? So my name is Ian, but my name is not the most important one you're going to learn today. It's the names of the people that you're working with. You're going to spend a lot of time with each other this semester. My office is just around the corner. My work number is there. My home number is there. The fact that my home number is on this paper means you're okay. It's okay to call me at home, okay? Don't feel badly. What's that? Yeah, those are my hours. All right, so feel free to call me at home if you need to reach me. Email is fine, and I promise I'll get back to you. But I don't have email at home, so that's not necessarily the best way to reach me. You email me Friday afternoon, I might not get it until Monday morning, okay? What's that? I live in Leverett. Yeah. Okay, so, all right, so my office hours are here. I just want to highlight a couple of them. Right after class on Wednesday and Friday, I'm available in my office. Specifically, I put those hours there to help you guys. I'm available other times as well, and I'm available besides just the stuff that's listed. Come find me and we'll work something out. I also want to say that the Math Studio, which is this big, beautiful room right across the hall, is a wonderful resource for you as you are doing homework and learning and studying for tests. In particular, the Math Studio is covered by a math faculty member right before this class from 12:10 until 12:50. So basically the hour before this class, that room is covered. So I'd encourage you, I don't think any of you has class between noon and 1 on Monday, Wednesday, Friday. I'd encourage you, if you can, to build that hour into your schedule. Just think of it as part of this class, an extension to this class. And if you do that, I bet you'd find a bunch of people in this room now just working over there right before class every day on homework problems and studying for quizzes and tests, and also getting help from Bob, who's the person who's going to be staffing it. I'll give you a schedule with the hours for when the studio will be covered. Okay, the textbook information is there. I want to highlight one line here. That's not how we highlight. Sadly, the bookstore will not buy the textbook back for this class. It is specifically designed for this class at GCC. So there isn't really any resale value in terms of the bookstore. You might be able to sell it to somebody else who's going to take this class next semester, but just wanted to put that there. Next thing, I wrote something that wasn't true in here. I have this sentence that says, I've crossed it off and you're welcome to cross it off too. It says the course may not be used to fulfill degree or certificate requirements. That is not true at this moment, but at the end of this semester, it will be true. There's going to be a shift in terms of how this class counts. This is the last semester at GCC where this class can count as one of your electives. If you're a liberal arts major, you know you have like 22 credits of electives. This is 4 of them, and it counts right now. But if you do not pass this class this semester, and you take it again in the summer or the fall, those 4 credits will not count on that big piece of paper in order for you to get your degree. It's a change. We needed to align ourselves with the greater community colleges here in Massachusetts, and it's changing at the end of this term, okay? More incentive to get through this successfully this semester. All right, I think I might be getting near my 2 minutes, so we'll probably wrap this up. Where are we here? You're going to read through lots of stuff. Your grading option, well, the way you will be graded is there. Stuff about Moodle, stuff about special needs, and then finally, this thing right here. There will be some quests. We'll talk about that. Was that the question? We'll talk about it. Okay. I do want to call your attention to the thing that's on the last piece of paper inside of the back. That's our calendar. We're going to look at this at the start of just about every class this semester, but I'm going to pull up an Excel version. It's the same thing. And there's a lot of info here, so let's be clear on what I've given you on that document. The first column is the date. Today is January 25th. Second column is the class number. This is class number 1. When we meet again on Monday, that'll be class number 2. Those numbers are referenced in the big packet. I think it's a really nice way to keep track of where we are and where we're headed. On the very first page of the big packet, up here in the top left, it said class number 1. We'll get there at the end of class today, but if you keep going, eventually you will find this phrase, learning objectives, after class number 1. That's the formal end to that class. And then when we pick up again on Monday, we will start here at class number 2, okay? The reason that I really like having the numbers is that I cannot guarantee that there won't be a snow day between now and February 4th. Let's go here to February 8th. But I can guarantee you that the 7th time that we meet each other in this classroom is when we're going to have our quest, okay? So what's a quest? Well, we'll talk about it. It's like between a quiz and a test. It's a full period thing. I don't know it'll be February 8th, but I do know it'll be the 7th time that we meet each other in this room, okay? So the class numbers are there. That column right there is the schedule for all of the quests and the tests. There's info about them on the syllabus. The next column talks about the section number that we're going to cover in the book. This book, again, was specifically designed for this class. It's actually 2 different books with different sections brought together, so the page numbers are sometimes inconsistent, and it can be difficult and frustrating to find where is the homework, where are we today. I've done my best to include all the page numbers here, and then in the back of the book, it can also be frustrating to try to find the answers. I'm sure there's some errors in here. There's too many things that I typed for it to be perfect, but if you find any, let me know. It should be pretty good. And then the last column is the topic. Today we're talking about solving linear equations, okay? All right, any questions on any of that stuff? Thank you, I do my best. Okay, so let's come back to this big packet, and we're here at the top of page number 2. And I think we're up to Dave. Can you read number 4, please? Describe what you know about this equation. Okay, y equals x plus 4. It looks similar to the first couple of equations, but there's a real big difference between y equals x plus 4 and 5x plus 3 equals 23. What is the fundamental difference between those 2 equations? They look really similar. There's the y. Yes? This equation has only one variable, is x. This equation right here has 2 variables. Well, that's the first thing we notice. 2 variables. And when we graph that equation, which we're going to do together here in a minute, we're going to get something. Do you guys know what the thing is called that we're going to get when we draw it? It's a line. It has to do with slope. We'll talk about slope. But the graph of this thing right here is a line. So where is that line? Is it this line? Is it this line? Is it that line? I don't know. We got to do work to figure out where it is, but it's some line, right? When all is said and done. Okay, I think it was Drew that talked about some of the equations of lines, and one of the equations that Drew gave us was y equals mx plus b. And we'll talk in detail. Right now, this is just trying to shake off some of the rust, because I think you know some things about equations of lines already. But we've talked a little bit about what that thing represents. What's it called? It's the slope. Slope is a measure of how steep the line is. This guy we have not talked about, but does anybody remember what the b represents? The y-intercept. I'm going to kind of put this off on the side. We don't need to know any of that in order to do what we're doing, but just, again, trying to shake off some of that rust, maybe. Let's go down here to part A. Dan, can you read A, please? Okay, so let's give this a shot. You can pick any numbers that you want. Let's go to, I lost it. Jody Ann, can you pick your favorite number? 2, wonderful. Give me something negative. -6, great. How about right here? 7 is wonderful. Then we'll go back over to Katrina. Pick something else. 4 is good. What I'd like you guys to do is those 4 numbers, could be any 4 numbers, but let's all do those 4. Plug them into the y equals x plus 4 equation. What are those numbers? What letter? Those are the x's. So you're going to plug those numbers in for x, and you're going to find the y. I'll do the first one. It's 6. Make sure you see where we got the 6, and then fill in the rest of that table with your neighbors. Okay, so as people are winding down, we'll come back together as a group. So we fill in the table, plot the points, and I made the same mistake that somebody else in this class made, but it's good to make mistakes. We learn from them. You can see there's a problem looking at my picture, right? This thing isn't supposed to curve, but all right, so which one is not like the others? Yeah, the one on the far left here. Okay, so somehow I messed up my -6 and 2 line, so that's this line right here. So what should it be? It should have been -2. I made an easy enough mistake to make. I can pretend I did it on purpose, but I didn't. So you fix it. You don't just draw something curvy. You You see something that's wrong and you identify it. So that's what we do. So we'll fix this, put it -6, -2. That looks a lot better. And then we connect the dots. If you have a straight edge, you use it. Hey, that's not bad. What else can I put here? Okay, one little thing. Sometimes people draw that and they stop. What's the problem with that? Yeah, the line continues, right? I mean, the line doesn't care what points you picked for the table. So it doesn't depend on what points you decided to pick. So don't do that. Draw the lines and extend them past the points that you pick. And then there's a real easy way to indicate that you know that they go forever, is put arrows on the end. Okay, so I'm not going to be so particular that I take points off if you ever forget to put arrows on the end, but just putting it out there, it goes forever. Okay, let's take a look at this down here, part C, and we'll go to Jody Ann. Can you read part C for us, please? Okay, thank you. So there's a bunch of choices here. Now, I want to use the graph that we just came up with. You don't need to use the graph. You could do something like this. Let's take a look at the last point, 6, 2. If I plug x equals 6 in, what do I get? 10. Do I get the y value? No, so it didn't work. 6, 2 is not a solution. That's fine, and you could do that for each of them. But I want to really think about getting information from the graph. So let's look at the graph, and let's look at the point 6, 2. So the point 6, 2 is right here. How can you tell that right away 6, 2 is not a solution to that equation? It's not on the line, right? That line is supposed to represent every single solution. We found 4, the 4 points that we plotted, but every single solution to that equation is somewhere on this line. And every point that's not on the line is not a solution. So can you do that kind of thing and either say yes or no to each of these points? Okay, so we'll come back together. Seems like most folks are finished or finishing up. 3 yeses, 3 nos, and it's very quick by looking at the graph. Yes? Okay. Moving on to part D, it says on this same graph above, graph the line which represents all the solutions. We did that already, Katrina has pointed out. I guess technically it only said plot the 4 points up above. We went ahead and drew the whole line, so that part's done. But we move on to part E, and I think we're over here to Ben. Ben, can you read part E? Okay, so the quadrants have numbers just to make them easy to refer to. You just have to memorize it, but maybe we can come up with some good way to memorize it together. If you have any inspirations over the weekend for how to memorize it, let us know on Monday. Anybody know where quadrant 1 is? Okay, what is a quadrant? Good. All right, so first, the word quadrant has QUAD in the front. What number does that represent? Represents 4. All right, so QUAD is 4. So there are 4 different sections that the entire front wall has been broken into. Top right, top left, bottom right, by the 2 axes right there. So we just know, we call them quadrants because there's 4 of them, and we number them just so we can talk about them. So where is quadrant 1? Top left? A few votes for top left. Any other votes? 1 vote for top right. Other thoughts? It's okay if we haven't seen or we just don't remember. Turns out it's the top right. That's quadrant 1 right there. So the only thing that I can say about why we call that the first quadrant, yeah, I think that's it, Katrina. Can you say it again? Yeah, like this point right up here was +2 and +6. That's the place where all the numbers are positive, the x's and the y's. I think that's why we call it the first one. I think. Who knows? Most what? Yeah, that's true. We only do positives in the beginning. And then it turns out, it seems like maybe we should follow the clockwise to go to number 2, but we don't. We go the other way. Number 2 is here, and it follows counterclockwise all the way around. Also, the convention is to use the Roman numerals. So this blue line passes through 3 different quadrants. Go ahead and write down the numbers that are the quadrants it passes through. Okay, which ones does it pass through? 1, 2, and 3. All right, here's a thought question. Don't just shout the answer out, but give people time to think about it. Is it possible for a line to pass through not 3 quadrants, but 2 quadrants? And if it is, go ahead and just draw a real quick, don't have to worry about being very accurate, just draw a quick line that passes through 2 quadrants only. This guy, yeah, this is good here for 2 quadrants. That's like 2 different lines or curvy something. Yeah. All right, you have something there? Perfect. I want to know, is it possible? So this line goes through 1, 2, 3 different quadrants. I want to know if we could draw another line that passes through only 2 of them. And the answer is yes, and I actually saw a couple of different kinds of lines. I saw some people draw a horizontal line. Great. I saw other people draw a vertical line. Great. Those are special because if it's tilted, it's going to eventually angle off and go elsewhere, right? But there actually are 2 people in this room that found a tilted line that hits exactly 2 quadrants. What's that? That's very fancy. We're only doing line stuff right now, but I love the creativity. So I found 2 people that drew this line right here. Very sneaky, right? It should hit another quadrant, but 2 people in this room said, wait a minute, if I sneak through the origin, then I can kind of cheat the system. I like that. Okay, is it possible for a line to hit only 1 quadrant? Can a line hit only 1 quadrant? I don't think so either, right? I mean, if it goes forever, it's eventually going to hit. Yeah, like this. But is that a line? Yeah, that's a ray, right? That's great, except it's also ray. Lines go forever both ways. Yeah, so can't do it through only one. Can we go the other extreme? Can you draw a line that hits all 4 quadrants? Yeah. Okay, it's not a line. It's not a line. But that's okay. We can't do it. Not with a line, right? You need something to curve. We'll talk about curvy things later on this semester. Okay. Last question right here is part F. Glenn, did you read yet? Go ahead, please. Okay, so here's the question. Is that line right there increasing or decreasing? And it's really kind of a matter of perspective. If you are walking on this line, imagine this is a road and you are looking at yourself from the side and you're walking on this line from left to right, are you going uphill or downhill? Uphill. If you go left to right, you're going uphill and you'll feel that kind of burning in the quads and the calves, and that's great. So in some sense, the line is increasing. But if a friend of yours is going skateboarding back the other way from right to left, which way are they going? They're going downhill. So in a very real sense, this line is also decreasing. Well, we can't have 2 different answers to this question. So everybody in the world picks something. It's kind of arbitrary what we pick, but it's your job to now know what we pick because that line is not both increasing and decreasing. Here's what everybody in the world picks. Whenever you walk on a line, or on any curve, you walk left to right. You always walk left to right. I'm going to write that down because that is fundamental and it is always going to be true. Always walk left to right. And I'm going to say something else here. Might be a little bit silly, but maybe it'll be memorable for you. If we're trying to decide whether a line is increasing or decreasing, you are going to read that line. And I say read because how do we read here in English? Left to right, okay? We read left to right. If we were at a Jewish school and we were talking about Hebrew, I couldn't say this. But here in English, we can talk about reading the line. You want to know increasing, decreasing? You read that line. Is this line increasing or decreasing as you walk left to right? It is increasing. Yes? Everybody see that? Good. So that's the answer to this one. And a real quick graph over here. draw a line which is decreasing. As you walk left to right, I want you to walk downhill on a line that you're about to draw. So draw something decreasing. And maybe you end up drawing something like this here in green. As we walk left to right, always read the line left to right. We are walking downhill. Everybody understand this increasing, decreasing business? Okay. All right, so after we do in class a bunch of stuff together like we have just done, you will oftentimes find this thing called a group activity. This is where for the rest of the period, we have about 22 minutes. You're gonna need all of it. This is a long group activity. You guys are gonna work with each other on this group activity. There are a whole bunch of problems to do here, and then a whole bunch of problems to do here, and it keeps going. I think this is longer than most group activities, but again, we're just trying to refresh our memories. I don't expect 22 minutes is enough time to do all of this now. See how much you can get done. The answers are right here. I do my best. I think I included an answer key for every one of these group activities. So double check the answer key, check in with each other, and I'll walk around and help out. These things here are not officially part of the homework. We'll talk about the homework in the last couple of minutes of class today, but you're going to want to do them if at all possible. So see how far you can get.